where we're seeing climate change unfold faster than anywhere else on Earth. Here. In fact, temperatures in the Arctic and boreal regions are rising nearly 4 times as fast as those in the mid-latitudes. That's why NASA has teamed up with local partners to better understand the vulnerability and resilience of these ecosystems, while also gathering valuable data that will help future Earth-observing satellites. From space, air, and on the ground, we'll see how scientists are piecing together the story of the Arctic, from how it is changing to what that means for our planet. Because as they say, what happens in the Arctic doesn't stay in the Arctic.
DPA is engaged, and we're radiating.
One of the best ways to track how an environment is changing is to observe it from above. But where weather and vegetation can make it difficult to see the ground with the naked eye, specialized radar can pierce the clouds to give us a crystal clear look at the landscape. This special device, weighing nearly 1,000 pounds, collects data about soil moisture, vegetation, permafrost, and other environmental processes on the ground below. In fact, it's so precise that NASA developed a special system for pilots to fly the exact same flight path year after year to get an accurate reading as to how a landscape is changing over time.
So with the airborne data, we can target exactly where we want to go and exactly when we want to go there, and we get very high resolution data, so we can have a really clear picture of what's on the ground.
That's Dr. Liz Boyd, senior scientist for NASA's ABOVE mission. ABOVE has spent the last 7 years studying environmental changes in the Arctic and boreal regions. The mission uses satellite, airborne, and ground data to get a complete picture of what is unfolding in these ecosystems.
So our satellite data gives us a very broad picture of what's happening all over the landscape. And then with our airborne data, we can target specific locations and times when we want to get imagery. And then we can compare both our satellite and our airborne data with what's happening on the ground. We have teams actually out on the ground making measurements. And putting all that together is really where we get a lot of the power of what we're able to study.
And it all gets put together in Alaska. On the ground, these large dishes are used to communicate with NASA's Earth-observing satellites. Here, the data is downloaded and made public, which helps scientists connect the dots between what we see from space and on the ground. But why are these dishes in Alaska?
So the reason why a station like ASF is built in Alaska is because Earth-observing satellites, if you think of their orbits, they converge in the polar regions. So in Alaska, we can see the same satellite more often than in the lower 48.
In fact, this facility is in the perfect position to receive data from one of NASA's latest Earth-observing missions. NISAR is an upcoming satellite that will be launched by NASA in collaboration with the Indian Space Research Organization. It will use radar similar to what is flown on NASA airborne missions, like for ABOVE, to measure fine centimeter-scale changes in Earth's surface.
What's interesting and unique about NISAR is that it's going to cover the globe regularly every 12 days. And it's going to do it at a wavelength or frequency range, so-called L-band frequencies, that are very useful for doing Earth observation. L-band will allow us to study ecosystems changes and deformations of the Earth's surface with higher accuracy and better spatial coverage than we can with current systems in space.
And in the Arctic, some of the most pronounced environmental changes satellites can observe are happening right down the road. And it all starts with this stuff. Permafrost is frozen earth, be it ice, soil, or even organic